Then we'll go through all of the different concepts that I want to go through here. So physical properties, Discord, go live, and oops, that's not what I want yet. This, live. Okay. And there you should be able to click on and go into the second PowerPoint there. So for this one, there isn't an actual assignment from this PowerPoint. But what there is there's some opportunities where I'm going to ask questions. So I might just call out names that I see in our Discord chat. Just unmute yourself, answer the question if I have called upon you, answer to the best of your ability, and we'll go from there. So physical and chemical properties. You should have learned some of this in grade 9. I know Mr. Yu was doing some of this stuff with the grade 9s, but we'll see. So we know that matter can change, and the idea is change will either be a physical change or it will be a chemical change. One of the assignments you're going to get next week is you are going to be asked to do an experiment at home where you have to demonstrate both a physical and chemical change. And the idea is you are not allowed to leave your house to grab any additional resources. It has to be something in your home. So for some of you, that'll be really easy because your mom or your dad are excellent bakers and they have lots of materials that you can work with. For others, it'll be a little bit more difficult if you don't have a lot of food lying around in your house. You'll have to grab maybe some cleaning supplies or something like that to do an experiment. So the idea here is we want to know if these changes, so all of these little pictures here, we want to know if those are going to be physical or chemical changes. So let's define those first. So we're going to talk about physical properties, and then we'll talk about chemical properties, and then we'll define physical and chemical change. So physical properties of water. All of the earth depends on water. Among the First Nations and Métis people, water is treated with great respect. It's considered sacred. You'll also know that as Jesus was, or as God was creating the earth, water was one of the first things that he shaped into creation. So for us, it obviously has a lot of importance. And what a lot of you also learned through the simulation is that without rivers and lakes, trying to exist as a country or as a nation was very, very difficult. About 70%, I think it's roughly 74% of our bodies are made of water. Some plants are 95% water. And so one of the jokes that I like is I can walk on a baby, and a baby is 70% water, so that means that I am 70% Jesus. It's a really inappropriate and horrible joke, but there it is for you. And so water has a couple of different properties. One of them is cohesion, the other one is adhesion. In terms of cohesion, when we were handing out the graduated cylinder around the class, what you saw was that some of the water climbed up the side of the glass, and that gave us what the meniscus was. So if you remember, the meniscus was if we have the graduated cylinder and then we have a little bit of water, the water would have curved like this. Would have curved like this, and so then you would have measured from this point here. And so part of the reason that water does that is that water is attracted both to itself and it's also attracted to the sides of the glass. So water being attracted to itself, that is cohesion. If you've ever poured water on a table, you'll notice that the water kind of pools and collects together. It's because water is super narcissistic and it's attracted to itself. Water also sticks to other substances, and that is called adhesion. So this example here with the little penny, I wish we were in class because this is a really fun test to do. We did it with a nickel, because my last name is Nickel, with the grade 11s, and I think the record was 107 little water droplets they were able to get on one coin. And that is totally because the water wants to stick to the coin, but the water also wants to collect together and keep all of the water together. So it doesn't actually want to spill over the sides. It wants to just stay on the coin, which is kind of interesting. So those are the different properties. Those are the different physical properties of water. Physical properties include all of these different things. It is a characteristic of a substance that can be observed or measured without changing it. So some physical things would be color, melting point, boiling point, the density, solubility, the ductility, the crystal shape, the conductivity, the hardness, the texture, and the malleability, so the ability of it to break. All of those things are physical properties. So again, things that you can see and they can be observed without actually changing the actual substance itself. Chemical properties. Those are different. Those are the characteristic of a substance that describes how it reacts when it changes into a new substance. So this is a key little phrase here. Ooh, that was rough. Let's try that again. Eraser. When it changes into a new substance or substances. And a chemical change, the idea of that is it always results in the formation of a new substance or substances with different properties. And a chemical reaction, which is what we are going to start studying, is a process where chemical change occurs. So an example of chemical change would be a banana rotting. What actually happens with bananas and other fruits when they start to rot is something called oxidation. And so that's where oxygen comes, and oxygen reacts with the peel or reacts with the potassium found in the banana and causes it to age. Your body is also experiencing oxidation. And sometimes what that oxidation can turn into is it can change your cells into something called oxidized or free radical cells. And those are often shown with a little symbol like this. And sometimes, and in a lot of cancer cases, this is what's actually happening, is your cells are aging or being changed chemically to the point where they become free radicals or to the point where they become oxidized. And those oxidized cells do not work properly, but what they do is they start spreading to all of the other cells that are nearby. So if R was one of our types of cells, that would start spreading to all these nearby cells, causing them to also be oxidized. So some chemical properties would be absorbing heat during a reaction, if something is combustible, if something forms gas when it's heated, if something reacts with an acid, if something reacts with water, if it emits heat or light during a reaction, or if it forms a precipitate, or a precipitate if you prefer. That's what a precipitate is. It's like the white cloudy stuff in that mixture there. So those are all the examples of chemical properties. Again, these are things that are changing by a result of us adding something in or the result of us heating something up. Those are the chemical changes that exist. So some clues that a chemical change has taken place. There are 5 kind of main clues. One would be a color change. One would be it emitting heat. One would be it emitting light. 4 would be it forms a precipitate. Or 5 would be it is difficult to reverse. So those would be all of the kind of chemical changes there. Color change, emits heat, emits light, forms a precipitate, or is difficult to reverse. So looking at a couple of these examples here. Aiden, let's look at the apple there. Apple's being sliced in half. Is that a chemical or a physical change?
Physical.
Beautiful. Muy caliente, mi amigo. Abby, your name also starts with A. Let's look at the toast here. We have bread becoming toast. Would that be a physical or chemical change? Now we get to see who knows how to unmute themselves on Discord. Abby, what do you think? Physical or chemical change for the toast? Well, she unmuted herself. Brock, what do you think? Physical or chemical?
For which one?
For the toast. This one here.
Physical.
Physical? Are you sure? Why would it be a physical change? What do you think?
I'm just guessing.
Well, if we're toasting bread, are we adding heat to it?
Yes.
We are, right? Can you reverse toast being untoasted?
No.
You cannot. So this would be an example of a chemical change. Let's look at a different one here. Let's go to the eggs up in the top right-hand corner here. Jonah, Tebow, what do you think about this? Physical or chemical change?
Yes. The eggs.
Yeah.
I would think that is chemical.
I would agree.
Hmm.
So we know that this one would be a chemical. Okay. Aaron, a little hair example here. Do you think that would be a physical or a chemical change?
I would say that's a physical change.
Let's go back to the last slide here. If something changes color, that's usually
Oh,
a
I see.
chemical change. So,
I didn't see the color. I just saw
Yeah.
a cut.
oh yeah, that's fair. That's fair.
Then it's chemical.
Awesome. Let's go to this one here. The little tree in the bottom corner. Kiana, what do you think? Physical or chemical change? Oops, sorry. What do you think of the tree there? Physical or chemical? Luke Glass, hop in, save her. Is it a physical or chemical change? If a tree is being cut.
That's physical.
I agree.
Yeah.
Ryan Marco. Pumpkins here, physical or chemical?
Physical.
I would agree. Who else can I bug? Janae, the little cherry with the pie here. Do you think that would be physical or chemical?
Chemical.
I agree, that would be chemical. It's changing state. It's changing its entire appearance, so I would totally agree. Ihor, we have the little penny here. Do you think that would be physical or chemical?
That's chemical.
I agree. Let's do this top one here. Let's do the water. Let's go to Enoch for this one. The water up here. Do you think that would be a physical or a chemical change?
Chemical.
What makes you think chemical?
Oh shoot! Crap. No. Physical.
Why is it physical?
Mm,
Because it can be easily reversed.
Very nice. Yes, that's kind of the main thing, is it can be easily reversed. The other thing that it plays into, let me just click all the way back through my slides here, is this is looking at these 2 points here, melting and boiling point. So those two, the melting point and the boiling point, those can be changed, and those are physical things that are being changed. It's not that I'm changing water into something entirely new. I'm just simply melting or boiling the water, meaning that those two would have to be physical changes. I agree. Let's think about the same line of thinking here. Let's think about this little snowman here melting. Let's go to Hannah. Is that a physical or a chemical change?
Chemical.
What did we say about the water, about its melting point or boiling point?
Physical.
Yes. Because is snow water?
Oh.
Yeah. So snow is water. I actually don't know what this picture is trying to show, so we're just going to put an X through that. Fireworks going off. Who haven't I picked on yet? I haven't picked on Olivia.
Yeah, what is he done?
OJ. What's this one here? The firework going off. Physical or chemical change?
Chemical.
Atta girl. Yeah, that one would be a chemical change as well.
Chemical.
So that is all of the different physical and chemical changes that we have. Physical changes, some of these examples are kind of like on the fence in terms of which one they are. Physical changes generally are things that, like, without adding any extra chemicals or without adding a whole bunch of heat in, we can detect those things. Again, kind of the easiest way to see all of these different chemical changes would be a color change. If it's emitting heat, emitting light, that would mean like the object itself is emitting heat or light. Best example of emitting light would be this firework here. Something emitting heat. I don't know if we have an example of that. Forming a precipitate. That one we see a lot in chemistry, but you don't see it a lot in like everyday examples. Difficult to reverse. That's another one for sure. That's a good chemical change to see. So like the eggs, for example. It's very difficult to unboil eggs. I would be impressed if any of you were capable of that. So that is our second lesson there. So I'm going to discard those. I'm going to do this.